Hello guys, in this video we're going to be talking about the factoring flowchart. So the factoring flowchart looks a little bit like this. It is a method of how you should think about each one of these problems. So in a problem, you're going to have a series of decisions that you need to make. The first one being you need to look for something to factor out of everything. So that's the first example they're going to take a look at. In the factoring assignment packet, you're going to see in question number 2 that we have 3x cubed y to the second minus 18x squared y to the third. So what I'm going to do is think about each one of those terms. So if I think about what multiplies to give me 3, it's just 3 times 1. So I'm just going to leave that as a 3 right now. If I think about what gives me x to the third power, that would be 3 x's all multiplied together. 1, 2, and 3. And then what would give me y squared would be 2 y's multiplied together. So I expand that out so that each one of those things is written in its factored form. I can do that same thing with 18, but what I'm looking for is something related to 3. So if I can think about 3 times what would give me 18, that's going to be key. So my multiples of things that would give me 18 would be like 1 times 18, 2 times 9, and 3 times 6. Obviously, I could do just a little bit more, but there, right here, this is my multiple of 3 that I'm looking for would be 3 times 6. So then I have x squared. I could do times x because x times x would be x squared. We have 2 of those x's multiplied together. And we have 3 y's multiplied together because of that cube. 1, 2, 3. So now what we look for is what do they have in common? What's in both of those? Well, we have a 3 in both of them, so that's something that we can write as a factor on the outside. I look at my x's. I have 2 x's. That's the fewest number that they both have in common. So we're going to write that as an x squared because that's x times x. And then we look at our y's. What's the y's that they have in common? Well, we have a y times y and another y times y right there. So y squared also can be factored out. So that's all what goes on the outside of my parentheses. On the inside, I'm going to put what is left over. So in here, we took away the 3, we took away these 2 x's, and we have an x left over. We also took away both of those y's. So it's only that one x that remains. That would be 1x. Minus, we took away the 3, but we have a 6. We took away the x squared, and we took away 2 y's, leaving us with 1y. And that would be our factored form. With our factor and flowchart, we look to see with what's left, is that binomial a difference of squares? And this is not. This is not something squared. This is just x and 6y. So not something squared. So that tells us, looking at our factor and flowchart, with that binomial, that we are done. So that's just a process of ways to think about through each problem. In the next problem that I've selected, that is question number 10 here. This has 1, 2, 3, 4 terms. How we determine a term is by how many plus or minus signs are there. So each plus or minus sign splits it up. So we have a term here, that plus or minus sign, and then another term. Then another plus or minus sign, then another term, another plus or minus sign, and then our 4th term. So we have 4 terms. Looking at our factoring flowchart, we look for something that we can take away from each one of those things. So I look at 20, x and y. Does that share something in common with 12? And yes, they do. They both share a factor of 2, and they both share an x. So I look at 15. Unfortunately, 15 has neither a factor of 2 nor does it have an x. So that tells us we need to move on to our next step in the process. So with what's left, how many parts do we have? And we have 4 or more. So that's going to be a polynomial. With that, we have 2 things that we're going to try. Number 1 is factor by grouping, and the other one is that we're done. We can't do anything with it. So with factor by grouping, I look at these first 2 terms, and I look and see what do they have in common. Well, we just said that 20 is 2 times 10 times x times y, plus 12 is 2 times 6 times x. So the 2 that they both have in common and that x can be factored out, 2x. That leaves us with a 10y, 10 times y, plus 6. Then we look to do that same process with this next set of terms. So with 15, that and 9, those are both going to be multiples of 3. So 3 times 5 times y, and then that's going to be plus 9. That's going to be 3 times 3. So I look to see if is there anything that I can factor out of there. And plus, there's a 3 and a 3. I can take that out. 3 parentheses. What do I have left? I have a 5y plus 3. Now, you'll notice that these two are not the same, and that's because I have something not quite right here. Both of these can be broken down even further. So if I think about what would multiply to give me 10, that's going to be 2 times 5 times y plus 3 times 2. That's going to multiply to give me 6. So I can factor this even further beyond just that first term. Occasionally that'll happen where you have something that you don't quite get all the way done. You just didn't see that factor, and that's okay. So we're going to take out another multiple of 2. Well, we have 2 times 2, so that's 4. 4x. Then we have 5y left over, plus 3. Plus 3, parenthesis 5y plus 3. Now, these two are exactly the same. That's exactly what we're looking for. When we have the same common multiple between each of our terms, remember we look for a term is separated by addition or subtraction. So we have this is our common multiple, and this is our common multiple. We can factor that out. So we get 5y plus 3, in parentheses, 4x plus 3. Boom. There is question number 10. We look for that common multiple. We then factored by grouping. With question number 16, we're going to try that exact same process. So again, we reference the flowchart. We look for something that we can factor out of each one of those. And we have 12a squared. So that could be like a 2 or a 3 and a squared. Obviously, we're looking for an a. So 5 does not have a common number multiple, but it does have an a. But this 2 on the end doesn't have an a. So there's no factor that all three of these terms, again, we look for the addition and subtraction sign, so that separates these into 2 terms, and this separates these into 2 more terms. So 1, 2, 3 terms. So with that, we look at the trinomial. When we have 3 parts, when a is equal to 1, there's a particular shortcut that you can use, if you guys have seen that one. Or for anything when a is not equal to, or it could also include when a is 1, but when a is not equal to 1 in particular, we use the diamond puzzle factoring. So that's what we're going to do here. At the top, we're going to multiply those two numbers together. So we take this number out front, 12, times this number on the end, negative 2. 12 times negative 2 is negative 24. On the bottom, I need positive 5. So I'm thinking about what are all the things that multiply to give me 24. Well, I could have a 1 times 24. Since that's a negative 24, either one of these could be a negative number. Either the 1 could be negative or the 24. Again, we could do 2 times 12, and once again, either the 2 could be a negative, or we could have a negative 12. And then 3. We could have a negative 3 times 8, or a positive 3 times negative 8. Well, those actually have a difference of 5. If I think about, if I were to add these together, which one of these would be positive? Well, it's when the bigger number, this 8, is positive. So right here, that's the set of factors that I want. All the rest of those are ones that I considered, but don't actually need. So negative 3 and positive 8. So I go over here, and I break this down. We're going to do 12a squared minus 3a plus 8a minus 2. If I recombine those, that would give me 5a. But we're factoring. We're breaking this apart into its similar terms. And just like we did in number 10, since we have 4 parts, we're now going to factor by grouping. So I look for what do these two have in common? Well, 12, I know that 12 is 3 times 4 times a times a. Well, that is minus 1 times 3 times a. This is going to be plus 8 is 4 times 2 times a minus 1 times 2. So I look for what do each of those first two have in common. In the first two, I have a 3 that's in common. and an a in common. What that leaves us with when we factor out that 3a is that we have 4a minus 1. Back here, I look for, again, what do I have in common? Well, they both have a factor of 2. We bring out that 2, and we have a 4a minus 1. Those two should always be the same. Since those two factors are the same, we bring that common term. That whole thing is a common multiple between our two terms, and what we're left with is 3a plus 2. And that's our factored form when we have a trinomial. So thank you for watching, guys. That's how we use our factoring flowchart.